How's it going, guys? It is Wednesday, January 15th. This week on the podcast, which is, by the way, our 50th podcast, so that's pretty cool. I have Leemon Baird, CTO, founder, chief scientist of Hedera Hashgraph. This exciting fintech industry that we are witnessing today is more than just all these blockchain projects that I usually cover. Hashgraph is an example of that, and Leemon does a really good job of breaking down what Hashgraph is, how it works, and how it is an alternative solution to what we are hoping blockchain can be in the future. So anyways, it turned out to be a great episode, and I think you guys will thoroughly enjoy it. Also, as the podcast continues to grow, I would like to avoid running ads as much as possible. So if you enjoy the podcast, you can make a monthly contribution by clicking on the link in the description below. Every dollar helps grow and maintain the show, and any contribution is greatly appreciated. Plus, it's better than running ads. It really is. So click that link and let's keep this party going. As always, be sure to subscribe and share this episode with somebody that you think would like to learn more about blockchain or Hedera Hashgraph. All right, enjoy.
This is the BlockHash Podcast.
All right, Leemon, how you doing?
Hey, I'm doing well. How are you doing?
Very good. How's your day going?
Pretty good. It's a beautiful day here in Dallas.
Yeah, it's nice here in Vegas as well. So for the audience and the people that will be listening, some of them may be familiar with you, or they may not be familiar with you. And Hashgraph, can you give me a little bit of background on your backstory and who you are?
Oh, sure. So I'm Leemon. I was a computer science guy. I was a professor for a while. I've been a scientist in a bunch of labs. I have started a bunch of companies. And most recently, I developed Hashgraph and then built swirls on it to do private ledgers, and then Hedera to do public ledgers.
Did you work on anything before Hedera, or mostly just been on Hashgraph?
Well, before Hashgraph, I had a couple of other companies, and they were acquired. And I also worked in labs and had a bunch of research projects that were fun, that weren't companies. So this is my third and fourth company, and one of many research projects I've done. But I think Hashgraph has been the most exciting of all the projects I've worked on.
Yeah, it sounds exciting. I hear a lot about it. So tell me a little bit about what Hashgraph is.
Yeah. So it's a ledger. It means it's a set of computers that can come to an agreement on the order of their transactions. All the computers can submit transactions and they all agree on what order they're in, and then they all process them in that order. And to do it with Hashgraph, it involves just sending each other the bare transactions with a tiny bit of extra information, just 2 hashes. And if you do that, then every computer actually learns not only what the transactions are, but exactly how they flowed through the whole network. Every computer knows the entire history of how these transactions got gossiped through the network and just flowed out through the network. And it can look at this graph of how they all flowed through the network, and by virtual voting can just kind of figure out what the consensus order is without talking to anyone about it. So no votes are sent over the internet. It's all virtual voting. And so you just send out the transactions. If you want everyone to have the transactions, you have to do that. You add a couple hashes, and now you have enough information to know consensus, and you don't do any communication about consensus. But you get very, very strong consensus. It's asynchronous Byzantine fault tolerant. So ABFT is sort of the highest level you could do, and it's ABFT.
So how does asynchronous BFT differ from BFT, like with blockchain?
Yeah, so if you have blockchain like proof of work systems, they aren't even BFT. So they don't even have a moment in time where you know for sure that you have consensus. You just keep getting confirmations and you get a little bit more sure. Mm-hmm. Now, there are other systems like Raft that can give you BFT, where you are sure that you have a moment in time where you have consensus, but it isn't ABFT, which means you have to assume the internet works right. And if somebody can DDoS you, if they can flood one of your computers with packets from all over the internet, and shut down one computer at a time, they can shut down your whole network. So if you have a network based on leaders, you could be BFT, which means you will reach consensus if the internet works properly, but the internet may not work properly for you. And if you're DDoSed, they could shut down the entire network forever just by shutting down one computer at a time. If you are a BFT, then you're resilient even to that. Even if people attack you with DDoS attacks, as long as they're shutting down less than a third of your computers, you're fine. Now, of course, if they shut down all your computers, then you freeze. But they can't freeze you by just shutting down one computer or two computers at a time. So ABFT is the highest level of security for a consensus system.
Okay, that makes sense. So what kind of role do you have at Hashgraph? Like, what's your responsibility?
Well, so it's called chief scientist and CTO and founder, and I kind of do everything. So I do a lot of talking to people about the algorithms and the design and the architecture of what we're building. It turns out that a ledger is kind of a complicated thing, and it has lots of little pieces. And for each of the little pieces, you're constantly making new algorithms and new ways of doing it. And so I'm talking with the developers. We have a really good developer team, and I'm talking with them all the time about what to do with that. And then I'm also involved in figuring out the strategic direction of what should we be doing in the future. And then we're also involved in the council. So we're not just a company by ourselves. We actually have huge companies that each own a piece of Hedera and run it. And so I'm dealing with the council and making sure they know what's going on and that they are then able to make decisions about where we should be going. And so I'm involved in that. And so I'm kind of involved across the spectrum. And then there's personnel things, and there's financial things, and there's all the stuff you have to do. So it's kind of fun. I have kind of an exciting day with lots of different kinds of things going on.
That sounds fun. Sounds like you got a lot to handle just as one person.
Yeah, well, we have a great team. So the company has a lot of people in it, and they are really good people, and it's just wonderful working with them.
That's good. How long has Hashgraph been around?
So Hashgraph. In 2015, I was able to finally figure out how to do Hashgraph. I actually started like in 2012, but in 2015, I finally realized that it was possible. I had convinced myself it was impossible for a long time, but in 2015, I finally got that. I started a company to do private networks on Hashgraph, and it kind of announced itself to the world in 2016. And then when we got some traction on that, we were able to start Hedera for public networks. That was in 2017. And then we announced that to the world in 2018, early in 2018, started up our network in the summer of 2018, and then had open access later in 2019, where the whole world could use it. And so now for, 6 months, the whole world has been able to use Hedera. And so that's kind of the history of it. 2015, 16, 17, 18, 19. Something interesting happened each of those years.
Yeah, it seems like you had quite a bit of progression, and it's obviously been around for not too long, pretty new. So what did you think was impossible about it at first? Like, what was the breakthrough for you?
Well, that's the funny thing, is that we know how to come to consensus really fast. You can do that with a leader. Basically, just the leader tells everybody what order things are going to be in. The problem is if somebody shuts down the leader, they shut down the whole network. And we could switch to a new leader, but they could shut down that guy. So you don't have security. You don't have reliability. On the other hand, we knew how to have incredible security and reliability with voting algorithms that go back 30 years. But those 30-year-old algorithms involve sending lots of votes over the internet, and it was really slow. And so I basically, in 2012, kept trying to figure out a way of having both at the same time. And, I would play with it for a while and just convince myself it was impossible and set it aside, that you had to choose between speed and security. You couldn't really have both at the same time. And, I have a bunch of math problems that I just kind of work on from time to time because they're kind of fun. And a lot of them I'll probably never solve, but sometimes one will go for years and eventually I'll see the solution. And that's what happened here. And so that's always really fun when that happens.
Yeah, you sound like quite a math guy. Is that primarily your background?
Yeah, so computer science. I was a computer science professor, but I've always focused on the math side of computer science. So machine learning and coding theory, so like jam-resistant codes, radios, and then now Hashgraph. I've always kind of focused on algorithms and the math side of it, how to how to get the computer to do things. What steps should it go through? And even as a
Mhm.
kid, I was working on algorithms for computers, trying to come up with new things. So I've always liked that stuff.
Very cool. Yeah, that stuff is fun. So with Hashgraph, what's a
Mhm.
really simple way of explaining it? 'Cause, I mean, my audience is very diverse. There's a lot of people that
Yeah.
are that understand stuff like this on a technical level, and then there's also a lot of people that are
Mhm.
learning and trying to get into this space. So a
Mhm.
lot of them are familiar with what blockchain is, but
Mhm.
with Hashgraph, what's a really simple way to explain it for the
Yeah.
audience so that they can understand as well?
Sure. So any ledger, the whole point of it is to put the transactions in order. Each computer that's submitting transactions has to get it to all the other computers, and then we just want to put them in order, and they all have to agree. So the most fair way of putting them in order is to put them in order by when they reached the network, when they reached most of the computers. So how do you know when they reached most of the computers? Well, you could have every computer tell you what time it received your message. And then you could take that list of times and sort them and take the one in the middle. That tells you when it reached the majority of the computers. And so you could say, I'll say for each transaction, the official timestamp on it, the consensus timestamp, is when it reached most of the active computers. And then I could just sort them in order by those timestamps. And that would give me a consensus order. So that works well. But then the question is, well, I said it's when it reaches the active computers. Of course, if a computer's turned off and not playing with us, then we will just ignore it. It doesn't get a vote. So we need to all agree on which of the computers are active. And that turns out to be the hard part. And that's where we do the virtual voting thing. But conceptually, it's really simple. It's just if we all have this complete history of how we've talked to each other, and if computer X just wasn't talking to anybody during the period in question, then we'll all agree, well, computer X doesn't count as one of the active computers, and we just won't look for its timestamp. But if it was talking to everybody, if it sent out messages that reached everybody really fast, then we'll say, yes, it was active during that time. And so we will let it vote on when it received the transaction. And that's it.
So
Mhm.
can someone use Hashgraph today, or are there applications being built on top of it, or what's kind of going on right now?
Yeah, yeah. So in addition to the private networks with swirls, there's Hedera has this public ledger. Of course, it runs smart contracts. So you can develop on top of it by writing a smart contract that runs on the network. You can also, of course, write programs that just run on your computer but use the network. So we have people that have software that runs on their own computers, but it stores files on the network with revocation where you can know for sure that it hasn't been revoked yet. For example, you could put a hash of your driver's license onto the network in a way that you and the DMV, that issued you the driver's license, both have the hashes there, or both
Mhm.
have the signatures, both signed off on you putting it on the network. And then either of you could take it away by yourself. And so if you ever lose your driver's license, the DMV could take it away, and you could anyone who wants to know that your driver's license is still valid can simply look at the network. If it hasn't been taken away, they know it's still valid. So it's like a revocation service. So people can write programs that run directly on the network with smart contracts, or they can run programs that just run on their own computers but use the network as a single source of truth that the whole world can see, like in that revocation example. So that's two different ways to build on top of Hedera. But there is a third way. And this is the new thing that is kind of unusual. We are about to be offering a consensus service, the Hedera consensus service, which means you could stand up your own little private network of computers, but have Hedera doing the consensus, putting the transactions in order. And maybe the transactions are even encrypted. So Hedera can't even see what you're doing. But the order is being done by Hedera, which means you have all of the privacy and speed and cost advantages of a private network, but you inherit the trust of Hedera. So you trust Hedera if you trust that more than 2/3 of the computers are honest, any ledgers like that. In your private network, though, you don't have to trust that more than 2/3 of the computers are honest. You only need one computer honest. And if you're running one of the computers, you know it's honest. You get all of your trust from Hedera. And that's the HCS, the Hedera Consensus Service. And it's sort of a different way of doing things. People have often done the opposite, where all the transactions happen over on the side and the state, the information is stored in the main ledger. We're doing the opposite of that. We have the main ledger just does all the transactions, and then it's over on the side that you store the information. And we're getting a lot of people that are interested in that. So there's 3 different ways to build on top of us, but that's the newer kind of way of doing it. And that's the one that we're seeing the most excitement about right now.
Yeah, that's really cool. Have you guys had like any actual use cases with that lately with any like companies or individuals or different developer groups?
So we are getting, of course, the big companies that are building on this haven't released to the public their names and what they're doing yet. But what we're doing is we're getting these companies saying that they want to build big projects on this. One of the areas where we're seeing a lot of interest is in when different companies in a different market have to rely on each other for help, but they're also competitors. It's sort of weird. So think about the phone system, where when your phone is from one company, but when you're roaming, you actually have another company providing that service to you. Well, they have to somehow be paid by your original company. And so 2 phone companies are actually helping each other out and paying each other, even though they're competitors. Or in the airline industry, you see the same thing, right? If your plane breaks down, your airline will actually buy you a ticket on some other airline's airplane and get you onto that airplane. But then, of course, the airlines now have to pay each other. And so they're actually helping each other, even though they're competitors, and they're paying each other. All of that stuff is natural to be done on a private network. But as I said, they're competitors. They don't trust each other. And so they really want to have the strong trust, but they also want privacy. They don't actually want to broadcast to the world how often their plane broke down and they had to use someone else's, or how often you roamed to another company's network. So they want the privacy, but they also want the trust. And so it's ideal for us doing that. And then there's other applications that people are very interested in, is tokenizing things. Tokenizing things of value. So you can tokenize stocks and bonds and gold and other things like that. And again, you might want a private network there's a number of reasons why you might want to sort of have a private network, but you want strong trust. You want to be able to trust that more than 2/3 of the Hedera council is honest and our computers are honest, rather than just having to trust your little computers over on the side network, but because you have very valuable things. But having this side network is a helpful thing because it allows you to have greater control over it, and you can have privacy if you want, and maybe the cost is lower. And so people interested in tokenizing things are also very interested in HCS. So if you want a stable token or a tokenized stock or whatever, security token, all those sorts of things. So these are sort of the areas where we're seeing interest. You could also imagine interest in markets, like a little stock market or a little auction site or whatever, being an HCS kind of application. And I expect we'll see that as well. So that's kind of what we're seeing so far.
Yeah, that's cool. It seems like you can do a lot with Hedera already. And obviously trust and security are very, very important. Can Hashgraph scale to the degree that it would need to for some type of mass adoption, or for tens of thousands of, maybe hundreds of thousands of users to use an application built on Hashgraph? Like, what's the limit that you guys see for Hashgraph in terms of scalability? Can it compete with these other blockchains? Can it compete with these legacy systems like Visa, for example? What do you guys see out of it?
Yeah. So yes, it should be able to scale even without sharding. It should be able to handle a lot of transactions per second and a lot of users. And then with sharding, of course, there's no limit. So I can talk about what sharding is. Sharding is when you break up your network into little clumps. It's like a bunch of little networks that talk to each other. So with sharding, there's no limit as long as you have a nice pattern of transactions. But even without sharding, it is unusually fast. So right now, we've slowed our network down to a mere 10,000 transactions per second. Okay, so 10,000 a second is pretty fast compared to 7 a second on Bitcoin or 15 on Ethereum or whatever. 10,000 is pretty fast. But in the lab, it's running twice that speed, and we expect to be able to go a lot faster as we use GPUs for signature verification and other things. So we have extreme speed in just a single ledger with a single shard, a single group of computers that are all doing the same thing. And we expect to be able to ramp up that speed over time even faster. So we would be able to handle something like a Visa. I don't think that's a problem. But we will also be able to go to sharding. If you wanted 1 billion transactions a second, it's impossible to have a single computer doing that. You have to break up into shards. And we will be able to do that. And so we'll definitely do sharding when we need it. But right now, we are nowhere close to even needing to go to sharding. But we'll certainly be able to do that when the time need arises. And then as for storing information, if you're using HCS, that is the ideal thing for scaling, because you don't have to use the Hedera network to store your information. You can store it over on your side network. And so each app network is what we call them. Each app net will be able to have its own storage, and that scales infinitely. If you have an infinite number of app nets, then you have an infinite amount of storage. It's just the transactions per second that you have to worry about, not the storage. And Hedera can do a lot of transactions per second, and when it needs to, it'll do sharding and be able to do even more. So that's kind of where we are with scaling. It's one of the nice things about Hashgraph is that it is conducive to scaling. It helps with scaling.
Yeah, that is nice to have that option to be able to move to sharding if you really needed to get to that TPS limit. But in terms of people being involved with Hashgraph, like I know with Bitcoin and with Ethereum, there's the ability to mine or in some cases stake on the network. Is there some incentivization for somebody to be involved with Hedera, or does that even need to exist?
Yeah. So right now, it's just permissioned. It's the council members running the nodes. So we have these 10 council members, giant companies around the world in different jurisdictions under different governments, in different continents, different industries. So they're very diverse. And so they are running the nodes. But the plan is to then go to permissioned, but more than just them, and then go to unpermissioned, where anyone in the world can run a node. And of course, you do stake and get rewarded for staking when you run a node. In addition, when we start to move down that path, we will be implementing proxy staking, where people can, anybody who just has some coins in their account can proxy stake them and gets a very small reward for that too. So there will be ways to get involved in running nodes and in proxy staking. We haven't rolled that out yet, but we will be doing that at some point. We will also be rolling out some programs for incentivizing people to be building on Hedera and rewarding those that are driving the adoption of the system, that are building things that are actually used, that actually get customers. We'll be rewarding that as well. So we will be rewarding developers in those ways. And then also at some point, they'll be able to run their own nodes, and also people will be able to proxy stake.
Are you guys looking at proxy staking potentially in 2020, or is that something further down the line?
I'm not sure. It could be in 2020 or it could be further. It's not clear. It's not something that's really critical until we start going to lots of nodes beyond the council. But yeah, it will be coming at some point.
So regarding 2020, what are the plans for Hashgraph in this new year, this new decade?
Yeah. So we will be adding features like HCS, this consensus service. We will be There's a list of features that we will be adding, and we've talked about those. We will be making the network faster. We'll be making the network able to do modifications without having to freeze it during the modification, so it can be very fast. We will be adding additional little features along with the big features like the HCS that I talked about, and we'll be rolling out the state proofs that proves it in various ways. We have a mirror network. I haven't even talked about that, but these are nodes that watch the network and remember everything that's happened and allows you to do all sorts of data analysis on it. And right now, anyone can download the software and run a mirror node. That is available right now. And right now, a number of people are actually using mirror nodes. Like many of the exchanges, or maybe even all of the exchanges, are using mirror nodes to watch what's going on the network. So mirror nodes are already being used, and already third parties are running mirror nodes. And those will be improving a lot this year. Right now, it's just an early alpha version of the mirror node, but we'll be making it more powerful, giving it more insight into what's going on. And it will be able, of course, to be watching that the network's working properly. And we'll have all these watchdogs watching it, but they'll also have all the data. And they can have businesses reselling that data in various ways and processing it and doing data mining on it and all that stuff. So we'll be doing that this year.
Yeah, that's interesting. I didn't hear about the mirror network before. What does that entail exactly?
Yeah. So these are computers that are able to see what happens on the main net. They do not affect the consensus. So they don't do voting on what order the transaction should be in, but they find out what order the transactions were in. And they check the digital signatures to say, well, is it true that everybody on the network was agreeing with that? And so they can be verifying that the network truly did come to consensus. The consensus truly was this, and they can store that information forever. They can do data mining on that information. They can sell it to other people. For something like the HCS, your app net's going to need this stream of transactions coming to it after they've been put into order. And mirror nodes are what they would flow through. So you would maybe pay a mirror node to send you all of the transactions that are relevant to you. And so this is a business that can be built on mirror nodes. And so the mirror nodes are an interesting thing. They're sort of doing validation of all the transactions. They're just not affecting the consensus of the transactions. And they do make sure everything is true. Oh, another thing that will be coming is releasing the software. The bottom layer will be open review, and the layers above that open source. Open review means that you're allowed to see the code. But you might ask, well, how do people know that's really the code running on the network? Well, it'll be running on the mirror nodes, and they'll be checking continuously that the network is doing exactly what that code said it should be doing. And so it makes it impossible, even while we're permissioned, even while we have the council members running the nodes, it's impossible for them to be changing the state of the network in a way that doesn't match the code without getting caught. And they care about their reputations. And so they would have a strong motivation not to do that. And so these mirror nodes increase trust, they increase efficiency, they allow further business models. People could build businesses on top of the mirror nodes. And they're very interesting. And we have the beta versions running now. Third parties are already running those. You can download the software and run your own if you want. And that will be improving greatly this year.
What do you need in order to run a mirror node?
So you need a computer that has access to the internet. You can download the information. And at the moment, you need enough bandwidth to handle the transactions that are going through the network. As that goes up over time, you will need more bandwidth. If we someday go to sharding, then your mirror node would just be following one shard. So you'd only need enough bandwidth to handle the transactions flowing through that one shard. Unless, of course, you want to mirror several shards, in which case you need enough bandwidth to talk to all of them. You also need to do the processing. Right now, we aren't even using the GPU. So at the moment, you could run a mirror node with no GPU just fine. Someday, I think that we will want to use the GPU to get faster. But you can easily get 10 or 20,000 per second without even using the GPU. So, for the immediate future, you really don't even need a GPU on your mirror node. But someday, maybe you'll want to have a gaming PC that has a GPU, and that would be what you'd need for your mirror node. But at the moment, you don't even need that.
That's good to know. So I could just use my Mac if I wanted to and just download the software and set it up. I wouldn't need some giant 6 GPU rig.
Yeah, exactly. And it's not like proof of work where you really do need a supercomputer, a mining rig of ASICs and all that stuff. You don't need any of that stuff. Yeah, just an ordinary computer. You need storage, processing, and bandwidth. Typically, it's the bandwidth is the hardest thing. You just have to have a good internet connection that can handle the traffic. And right now, the traffic is lower than it will be. I think it's going to be growing rapidly. And so you just need enough bandwidth to handle all that traffic.
Yeah, that's awesome. It's cool to see how that mirror network works in tandem with Hashgraph. And it seems like you guys got a lot going on in 2020. Beyond 2020, I mean, what do you think the future looks like for this small but fast growing industry regarding I hate to say blockchain because that's too narrow, but like this fintech industry that blockchain and Hashgraph exist in.
Yeah. Or you could say DLT, distributed ledger technology, is what we're doing. So I think that this is an industry that is clearly in its infancy. There's this criticism. Yeah, blockchain sounds wonderful, but no one's actually using it. Okay. It is true that it is in its infancy, but there are a lot of very big players that are very interested in using ledgers for real world things that will truly increase the efficiency of real world processes and allow us to do new kinds of things we haven't been able to do before. And it looks to me like 2020 could be the year where you start seeing some pretty serious real world applications running on ledgers. I think we're going to see things in tokenization of value. We're going to see things in audit logs. I forgot to even mention things like audit logs and provenance when I was talking about uses of HCS. But that's actually where a lot of our early interest is in that. So you want to say, is this diamond, did it come from a conflict and some evil warlord had it, or is it just an innocent diamond? Is it a blood diamond or is it a good diamond? Well, you need to see its provenance, where it came from. Or you eat food or you take medicine, you might want to look at the provenance and trace where it came from. What labs did it go through? Are these places that you would trust? If you want to buy real estate, you might want to know, do a title search. Who actually owns the house that I'm about to buy? Has the guy who sold it to me also sold it to somebody else? And so those sorts of things, people have been talking forever about doing this on ledgers, but I think that we're starting to see real traction. I think that in 2020, we're going to start seeing real usage of ledgers for, more than just CryptoKitties, but real world organizations using it for real applications. And that's just the beginning. Over the long term, I think that we will ultimately find that every area of society ends up being touched by ledgers in some way. It's like saying, well, what's the internet useful for? Or what are computers useful for? What is ledgers useful for? You use them anytime that you want some kind of a shared database shared between people who don't trust each other. Well, our society, our economy, everything is full of information that needs to be shared between people who don't fully trust each other. So ledgers are ultimately going to affect every area of society. And you'll end up disintermediating things. You'll end up making things more efficient. You'll end up making things fast. And I think we're going to see it will slowly seep into every area of our economy and how our society runs.
Yeah, it's crazy to think about all the different industries that this technology or this industry can actually touch and how quickly it's actually starting to do that. It's very exciting to see where we're going. And I think this decade, 2020 going forward, is going to be pretty exciting in terms of the kind of developments we'll see.
Yeah, I agree with you. I think 2020 is when we start to see it really happening, but it'll, of course, continue throughout the decade. And this is going to be an exciting decade for this. I think that we've had the hype curve where everybody said this is fantastic and nothing happened. And now we're in the trough where some people are saying, see, nothing happened. And now we're about to come out the other side of that trough where then things actually happen.
Before we wrap up, are there any roadmap updates or things you want the audience to be aware of regarding Hashgraph? I know it's kind of redundant because we already talked about it a little bit, but if there's anything regarding Hashgraph that you wanted to mention.
No, I think it's just the things that we talked about, that there will be reward programs for people that are developing on it. There's going to be new features coming out. It's going to be improving over time in various ways. And I just really appreciate all the support from the community and all the excitement that I'm seeing right now. I appreciate it.
Are you guys on social media, or do you just do you have like a blog, or like where's a good place for people to get like more information on Hashgraph?
Yeah, so Hedera.com has blogs and videos, lots of videos, and then links to social media places where things are going on. And so all of those you can find links to them all from Hedera.com.
Okay, perfect. Leemon, thank you for taking the time to come on and talk about Hashgraph and everything today. I think a lot of people will definitely appreciate that. I'm very excited to see where it goes this year and in this decade. And again, thanks for coming on and taking the time.
Well, thank you. It's really been great. I appreciated talking with you. Thanks.
Yeah, anytime. Look forward to talking to you soon.